Alright, so we are going to work on the polynomial operations review for the test tomorrow. Alright, so it says to find the product of the following. So here we have 9, and then inside parentheses we have 2x minus 3. So since we have this 9 outside the parentheses, we know that we have to distribute that to both terms that are inside my parentheses. So 9 times 2 gives me 8, or 9 times 2x gives me 18x, and 9 times negative 3 gives me negative 27. So that would be my answer. Alright, so going over to the next one, the same thing, since this negative 5x is outside the parentheses here, and it's touching the parentheses, there's no plus or minus in between them, then we know that we are distributing that across the set to both terms. So when we do that, we get negative 5x squared, that's from negative 5x times x, and then negative 5x times negative 6 gives me a positive 30x. Alright. Here it's asking what the result of combining the terms represented by the tiles below would be. So remember that this is x squared, this is x, this is negative 1, this is a negative x squared, this is a negative x, and then this is a positive 1. Okay, so now I can see that these two positive x squareds are going to cancel out with these two negative x squareds, and I'm going to be left with one negative x squared. So I'm going to put negative 1x squared, or you can put negative x squared. It's the same thing. All right, and then I see that one of these positive x values or rectangles are going to cancel out with a negative x rectangle, and that's going to leave me with 2x rectangles. So I'm going to put plus 2x. And then out of my 1s, this negative 1 is going to cancel with this positive 1, and I'm going to be left with 4 1s, so that's going to be plus 4. All right. Number 3, it wants us to find the sum of the polynomial. So that means
1 plus 2.
We are adding.
What's 1 plus 2 like?
Okay. So
Negative 2.
What we have to do is recognize our like terms, and those are the ones that we're going to be adding. So I'm always going to start with the largest degree. Remember, that is the highest exponent. So that would be this 4x squared and then this negative x squared. So when I say 4x squared plus negative x squared, that leaves me with 3x squared. So that takes care of that. So now I'm going to go to the next one, which is going to be my x's. So I have this 2x and this 9x that I'm going to be adding together. So 2x plus 9x gives me, okay, thank you, baby, plus 11x. And then the last thing is our constants, which is this 1 and then this negative 3. So 1 plus negative 3 leaves me with negative 2, so that's going to be minus 2. So that's my answer. Okay, number 4, it wants us to simplify. So here we have a subtraction sign between the two trinomials that are in their set of parentheses. So since there's this minus in front of this set of parentheses, that means we are going to be distributing this negative 1 to each term inside this set of parentheses. And I'm just going to go ahead and rewrite it down here so I can set it up with its like term. So negative 1 times 3x squared gives me a negative 3x squared. And then negative 1 times 4x gives me a positive 4x. And then negative 1 times 4 gives me a negative 4. So now I have 8x squared minus 3x squared. I know that's going to give me 5x squared. And there's not anything that I can eliminate from there. And then 3x plus 4x gives me a positive 7x. So I can get rid of C and I can get rid of D. And then 1 plus negative 4, or 1 minus 4, gives me a negative 3. So that means A would have to be my answer. All right, number 5. Which expression represents the area of the shaded region shown below? Okay, so my shaded region is the darker part of the two rectangles. So what I need to do is I need to find the area of the larger rectangle and then the area of my smaller rectangle, and I'm going to subtract the smaller area from the larger area, and that'll give me the area of the shaded region. So we're taking the larger area, and we're going to subtract the smaller from it. I should have put L, not B. So larger area, smaller, minus the smaller area gives me the area that I'm looking for. Okay, so the larger area would be 6x times 5x, because remember we use length times width, or side times side to find, or base times height, whatever you want to say, to find our area. So 6x times 5x gives me 30x squared. And then the area of my smaller rectangle would be 2x times 3x plus 2. I have to distribute this 2x to both terms. So 2x times 3x gives me 6x squared. And then 2x times 2 gives me 4x. Alright, so now I have to subtract the 2. So I would be subtracting 30x squared minus 6x squared plus 4x. So again, remember we have to distribute this negative. So that would give me 30x squared minus 6x squared minus 4x. So here's my like term. So 30x squared minus 6x squared gives me 24x squared, and then I bring down my minus 4x. So my answer would be B. Okay, number 6. I need to find the sum between x squared minus 3x and x minus 1. So sum means we are adding. So I'm going to say x squared minus 3x plus x minus 1. Here are my only two like terms, so I'm left with x squared, and negative 3x plus x gives me a negative 2x, and I bring down the minus 1. So that means my answer is C. Okay, number 7. Okay, so we've multiplied two binomials with algebra tiles, and we got the product shown below, and it wants us to tell them what the product of the two binomials are. So remember, the product is always what's on the inside. So I see I have 1, 2, 3. I have 3x squared. And then I have 3 negative x's and then 2 positive x's. So 2 of these positive x's are going to cancel out with 2 of these negative x's. So I'll be left with negative 1x. Or you can put negative x there. And then I have the 2 negative 1. So I have minus 2. So that would be the product. Alright. So I need to find the product of the following. I can use the box or distributive or tiles. For this first one, I'm going to use the distributive property. So you can remember the FOIL. So we're going to use the first terms in each, or we're going to multiply the first two terms in both parentheses. So that would be x times 3x, which would give me 3x squared. And then I'm going to do the outside terms, which would be x times negative 5, which would give me negative 5x. Then I'm going to do the inside terms, so that's 4 times 3x, which would be a positive 12x. And then the last terms, which would be 4 times negative 5, which would be a negative 20. So these are my like terms. So that would leave me with 3x squared, and negative 5x plus 12x gives me a positive 7x, and then I bring down the minus 20. So that would be my answer, and like I said, we use the distributive process. Okay, so for this next one, we'll use the box. And we'll do it over here where it's asking us to. Or I guess that's what it's asking us to do. Alright, so again, it doesn't matter what order I use here. I'm going to just put this first one over here on the left, and then this second one up on the top. So 4x plus 2. So 3x plus 4x, that gives me 12x squared. And then 3x times 2 gives me 6x. And then negative 6 times 4x gives me negative 24x. And then negative 6 times 2 gives me a negative 12. So remember, these are my two terms that I'm going to combine. This reminds me to add them. So I have negative 24x plus 6x. So that would leave me with a negative 18x. So that means my answer would be 12x squared minus 18x minus 12. Alright, number 9. Which of the following calculator tables shows that the expressions entered into y1 and y2 are equivalent? So if y1 and y2 are equivalent, that means y1 is equal to y2. So that is what we're looking for. So A does not work out because you can see we start getting y1 and y2 values. Looks like B is going to be our correct answer because you can see y1 is equal to y2 all the way down. Alright. Number 10. X plus 3 and x minus 8 are factors of which polynomial? Well, in order to figure out which factors they go to, or which polynomial they go to, we're going to use the box method. Alright, so I'm going to put x plus 3 over here and x minus 8 on the side. So x times x gives me x squared, and x times 3 gives me 3x. And then negative 8 times x gives me negative 8x, and negative 8 times 3 gives me negative 24. Here are my like terms, and this reminds me that I got to add them. So negative 8x plus 3x gives me a negative 5x. So I'm looking for x squared minus 5x minus 24, so D. Okay, then over to the back side. Number 11. The diagram below shows the floor plan of a rectangular room. What is the perimeter of this room? So perimeter means that we add up the two lengths plus the two sides. So let's set it up like this, where we say it's 2 if this is my what L equals, and this is what, oh, I'm sorry, not S, but W, length and width. Okay, so I need 2 times the 5x plus 3 for my length, plus 2 times my width, which is the 3x minus 4. Well, now I got to distribute here. So when I distribute, I get 10x plus 6 plus 6x minus 8. Now 10x and 6x can be combined because they're like terms. So that gives me 16x. And then 6 and negative 8 are both constants that can be combined. So 6 minus 8 gives me a negative 2. So that means the perimeter is 16x minus 2. Alright. Number 12. The height of a poster is 4x plus 10 and its perimeter is 14x plus 24. What is the width of the poster? Okay. So I know that just the height of this poster is 4x plus 10, and I want to know what this width is. So, and all they've given me is the perimeter. So the perimeter, remember, is where I add up all the sides. So if this side is 4x plus 10, that means this side is 4x plus 10, and this is the side that I'm missing. So what I have to do is, I have to say, I'm going to have to multiply the height by 2. So I'm going to say 2 times 4x plus 10. So, and that covers both sides here. So that gives me 8x plus 20. So now I have to subtract. I have to take the 14x plus 24, and I have to subtract the 8x plus 20 because that's my height, added up twice. That I need to take away from it so I can find out what the value of the width is added up to itself. So when I subtract, remember I have to distribute this negative 1. So that gives me 14x plus 24 minus 8x minus 20. So now I'm saying 14x minus 8x, which gives me 6x. That's these two. like terms, and then I combine my constants 24 and negative 20, which gives me a positive 4. So remember, this is the width times 2, so what I have to do is divide everything by 2. So 6x divided by 2 gives me 3x, and then 4 divided by 2 gives me 2. So therefore, that is the width of the poster. Alright, so in the rectangle shown, a strip was cut off so that the remaining part is a square. What is the area of the original rectangle? So, if I want the area of the original rectangle, I have to add this little strip back on that was cut off. So that means I'm adding this 6 to this 3x. So now to find the area, remember that's the length times width, I would have to say 4x times 3x plus 6. Now I have to distribute the 4x to both terms. So that gives me 12x squared plus 24x. So D is my answer. Alright, number 14. If x equals 4, what is the perimeter of this equilateral triangle? So if it's an equilateral triangle, that means that all the sides are the same. That means every side is 3x plus 8. So what I'm going to do is, I'm going to figure out what this value is whenever I plug in what my x value is. So that means I would say 3 times 4, that's replacing the x with its value of 4, plus 8, so that equals, so 3 times 4 is 12, plus 8, that gives me 20. So now, that tells me each side is 20. And then to find the perimeter, I have to add these all up, or I could just say 3 times 20, because there's 3 of them, which gives me 60, so that means D is my answer. Okay. Number 15. Find the area and the perimeter of the rectangle below. So first for the perimeter, so remember, there's 2 of the 4x plus 7, and there's 2 of the 2x plus 3 that we have to add up to get our perimeter. So that means P equals 2 times 4x plus 7 plus 2 times 2x plus 3. So we have to distribute the 2, or both of them that's in front of the set of parentheses, to both terms. So then that gives me 8x plus 14 plus 4x plus 6. So 8x plus 4x gives me 12x. So these are my like terms that I'm combining. And then 14 plus 6 gives me 20. So that means the perimeter is 12x plus 20. Okay, now to find the area, I have to do my length times width. So that means I have to say 4x plus 7 times 2x plus 3. So this time I'm going to use a double distribution. So 4x times 2x, this gives me 8x squared, and 4x times 3, this gives me 12x. 7 times 2x gives me 14x, and 7 times 3 gives me 21. So I have to add these together, 12x plus 14x, that gives me 26x. So then when I write out the area in simplified form or standard form, it would be 8x squared plus 26x plus 21. Okay. 16. Which expression represents the area of the shaded region below, shown below? Okay, so again, this is where we have to find the bigger area and subtract the smaller area from that bigger area. So we're taking the larger area and subtracting the smaller area from the larger to get the area that we're looking for, just the shaded area. So my larger area is going to be 6x times 4x, which equals 24x squared. And the area for my smaller rectangle is going to be 3x times 5x minus 2, which we have to distribute the 3x to both sides. So that gives me 15x squared minus 6x. So now I'm taking the 24x squared and subtracting 15x squared minus 6x from it. So remember, when I have a negative or a minus sign in front of the set of parentheses, that means I have to distribute this negative 1. So that gives me 24x squared minus 15x squared plus 6x, because that negative is going to become a positive. So now 24x squared minus 15x squared gives me 9x squared, combining these two. And then I have to just bring down my plus 6x. So there was a mistake, so the answer is C. There needs to be a plus sign instead of a minus sign. 17. A pentagon has 5 equivalent sides. If all sides are represented by the expression 3h plus 6, what is the perimeter of the shape? Okay, so remember, if it's equivalent, that means every side for this shape, this pentagon, is 3h plus 6. So on and so on, right? And they're wanting the perimeter is where I would have to add this 3h. Oops. They're looking for the perimeter. That means I would have to add 3h plus 6 up 5 times, which is the same as saying 5 times 3h plus 6. So now let's just distribute our 5 across the parentheses, and I'll just write the answer down here. So 5 times 3h gives me 15h plus 5 times 6, which gives me 30. So that's my perimeter. Okay, so number 18. Rosa multiplied x plus 2 times x plus 3 and got x squared plus 5x plus 6. The screen at the right shows that Rosa entered into her graphing calculator. So part A, using the table feature, how do you verify that x plus 2 times x plus 3 is equivalent to x squared plus 5x plus 6? Okay, so again, here's that word equivalent, which means that what we're saying is that x plus 2 times x plus 3 equals x squared plus 5x plus 6 whenever we do our distribution. And that's here, this would be what our final answer would be. So if we wanted to check by our table, what we'd have to do is in y1, do x plus 2 times x plus 3, and then in y2 we're putting what the product of those two factors were. So x squared plus 5x plus 6. So now let's go to the table, and what we're wanting to see is that y1 is equal to y2. So when we look, you can see each value is the same, meaning they're equal to each other. So this is how we verify, is seeing that y1 is equal to y2. Alright, so if we were using the graph feature, how do you verify that the factors are equivalent to this product? So if they're equivalent, again, if y1 is equal to y2, you only would see one graph. So when you go to graph, and this always tells you whenever it's done right over here. So now it's done, you can see we only have one graph, so again it's showing us that the two are equivalent to each other, they're equal. Okay, so that concludes the review for the test. Be sure to study over any of the parts that you weren't really sure about, just to kind of make sure that you understand what you're supposed to do whenever, depending on whatever question's being asked. Like, make sure you are paying attention to words that you can use as clues to tell you what to do. So anyway, good luck to you all tomorrow, and I will see you then.